I wanted to show off a trick I've used a couple of different times for kind of creating simplified user branching for operators. So in a program, there are times when you'll have the user go back to common variables, and so they got to hit the parameter button. And if they've just started the machine up, they have to go to display change and go to common variables or press F1. Then they go in here and they set this, and they set that to a 1. And then you can go back to your program and you can press cycle start and it'll read common variable 1 and say, hey, if this is a 1, do this thing. There's a lot of room for error in that, especially for operators who are going from machine to machine and might not be familiar with different interfaces. You know, if you don't run Okuma often, getting in that habit of knowing how to get to common variables can kind of be a little difficult for some people to remember, and also recognizing that, you know, all operators are at different levels. So when you get somebody fresh off the streets, they're struggling just to get to the cycle start button and not crash the machine. So we want to try and create as many simplified solutions as we can for them. And one of my favorite ones is to use the control, and you know, this is just a simulator. Actual control has a couple of different buttons that you wouldn't see on here. Things might be a little different, but it's nice to create some additional logic based on certain things the operator may have pushed or may have not pushed, and incorporate that into your program. So right now this program just goes into this if statement, and I'm going to explain this in detail, but if this equals a 1, then go to the n line number or line word that says yes, and yes. If it does not equal to 1, or if this statement runs false, it's just going to ignore this and go to no, no. And I want to clarify, this is no different to the Okuma than creating n1 and n2 here. This would be n1 and n2 here. So don't let these n numbers confuse you as like system words or anything. They're just n numbers, but you can use letters on the Okuma as well. I like to use the letters because it makes it so that I can do something where I know there's no chance that the operator is going to confuse this with an n number in their program. They're not going to say, hey, go to n5 and then somehow magically jump into my program that they weren't even supposed to be in, running something they weren't supposed to do. So if you see anything at any time that starts with the letter N, at least as far as I can think of, there's no like system word that starts with the letter N. It's always going to be N, and whatever follows that, letters or numbers, it's just a value, a label that the Okuma is going to search for. So we're going to say, if this statement runs true, go to N yes. Go to is assumed. That's another thing that I thought was odd about Okuma. Oh, I saved this. Oops. Oh well. These are going to change after I reload this new program, so this might be a little confusing. So I'm going to put go to in here, and we're going to change these yeses to NP1s. Just to kind of prove this point. Whoops, I missed one of these. NP1 or 2. So just to kind of prove that point, you know, these n numbers are any value you want them to be. Go statements after a if statement are assumed. So if you don't have go to right here, it's just assumed that what you're trying to do is go to NP1. So we're reading back through this. If statement, if this is true, go to NP1. If not, just ignore this line entirely and go to the next line. Your next line is also a go to statement, which goes to NP2. That one's down here. It's also N0 or M00. So when I press cycle start on this, it's going to evaluate that expression. That expression came out to be false. The current condition of VORD, Victor Victor Oscar Romeo Delta, and 000D, that has a very specific meaning. It does not equal 1 right now. It equals 0. What that value is actually this button, the interlock release button, not just the button, but the actual light. So if an operator comes in and holds down the interlock release button and presses cycle start, all of a sudden they just branch to a totally different part of the program. So I've used this for things like tool life management. An operator puts a new tool in their machine. Well, part of that process for them was to go into the tool library, go into the tool life manager, find that tool that they just put in. Do not confuse that tool with another tool that's the same tool group, because that happened a lot. Restart that tool counter value and reset that tool to good. That's a lot of steps for an operator, especially somebody who's not familiar with the machine. All that this guy had to do was put the tool in. It was just a new drill. And the other step of that was to also touch off the tool. So I added this in here so that when the operator held down the interlock release button and pressed cycle start, what would happen is it would look at the current tool in the spindle and clear the not good tool state for tool life management. It would set the tool count back to 0, or basically if it could run 100 parts, it would set it back to 100 so that it was a fresh tool. And then it would also touch that tool off and put it away. So this allowed operators to kind of step through more quickly on their tool management systems and not even have to really think too hard about it. They just had, all that they had to know was, okay, I've got tool 12 on the spindle, which just has to be a 1/2 inch drill. They put it in there, and then they hold interlock release and press cycle start. Everything after that's all managed by the machine. These are called your vertical function keys. We're going to go down to this button. If you see anything other than this, likely whatever this bottom button is, will get you back to this main page. People are also often on this button, so if you hit that again, this is your main vertical function screen. This machine with the health icon, give that a click, and then you'll find the I/O monitor right here. So when we click this, this opens up a Windows application that's actually actively watching the inputs and outputs of your machine. All inputs and outputs that exist on your machine will be listed on here. It's a lot of inputs and outputs though. Over 1024 times 8, because each address has 16 bits. So there's a lot of values in here. It can be a little confusing to try and scan through a lot of these, but there's a couple of quick things that you can look at. So anything that begins with the letter O, lowercase o, is an output. Anything that begins with the letter I, lowercase I, is an input. Anything that's followed with a lowercase p, whether it's input or output, is going to be associated with the panel. So just kind of scanning through these, like axis, selector, X, PB, usually that's in reference to the pulse handle. Anytime it says PB, I don't have my pulse handle on this since it's just a simulator. But, oh, well, it looks like they've associated, and it's kind of confusing with this simulator. I've never done this on the simulator before. So, yeah, pushing this button, you see that that light lights up. Now when I let go of the button, it turns that off, and that'll be the same experience you'll have on a real machine. So generally I come over to the output side because usually these buttons all have little lights on them. Let's say we want to use that interlock release button. So clicking this off and on, I got lucky. I can see right here that this one's flipping off and on. That doesn't always happen. Sometimes you'll page down, look for a couple other ones, hit the button a couple of times, and you'll just have to kind of keep scanning through. There's I don't know, 40, 50 different panel outputs. Once you get down to here, we're out of the panel now. There's no more panel outputs here. So if you're getting clear down here, it's quite possible you've missed it. They do add some additional panel outputs near the bottom, like down here, but those are only if they're additional options. Things like this machine has turning mode, so they might have those options further down in the list. So, whoop, I just saw them too. There's some more panel outputs here. I learned today that here's a trick that I use. I put this in physical. That'll remove all of these with the letter L. Anything with a L on it is a logical and doesn't have a physical output. It's logical only. There's a whole lot of reasons that exists, but on my simulator, when I push physical, all of a sudden some of my buttons stop working. So I won't be able to see any more of my lights. So yeah, on my simulator this button doesn't work, but in the real world, definitely use this button because now I can only see my physical outputs associated with the machine. So I know that this OP mill is my interlock release. So when I flick that off and on, I should be seeing that turn red. It's not, but it's just a glitch in this particular simulator. That button works, I promise you, under normal circumstances. So turning that back to logical for my purposes, when I flick that off and on, I see that light lighting up. So I've got 512 is my my byte address, and bit is my 13. So with that information, I can go back to my program and I can set up a VORD, my variable output read data. My first three numbers are this minus 512. That's a little confusing to people, but inputs always start at 512 on every Okuma machine that's ever existed as far as I'm aware. So you'll just subtract 512. I've got 512 and 13, so I subtract 512, which just gives me 3 zeros. And put your leading zeros in, please. It will mess you up. The D comes in from hexadecimal. So I run out of numbers here. I can go 0, 1, 2, 3, all the way up to 9, but I cannot put 10 in here. If I do a 10, this will alarm out because it's seeing these leading zeros. It messes the whole thing up. So you're gonna have to figure out the hexadecimal. It's pretty straightforward. 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and then 15 is F. Since I'm looking at 13, I can just put a D for delta there. Program select that, and now as we were looking at it earlier, pressing cycle start takes me to NP2, turning my interlock release light on by pushing the interlock release button. I would have to hold it in the real world. They make it clickable on this simulator. But turning that light on allows the program to branch differently. So in conclusion, this is a wildly useful function of the Okuma machines. I believe it's included in all of the machines that have user task 2, which has been standard for 30 years, I believe. I've never seen a machine that you can't use this in. So just a reminder, anytime you're looking at the outputs, make sure you subtract the 512, use a letter for anything over the number 9. Inputs, if you do use those, that's going to be VIRD, and then everything's the same. You don't have to subtract the 512. Hope you have a great day.